We're back. Okay, so what we're going to get is we're going to get Q to S. Okay, which is this part here. Now we have the triangle SQR. So it says get QS. QS can be achieved by using Protractor's theorem. Protractor's theorem being x squared equals 12 squared plus 22.5 squared. What do you get when you put that in the calculator, Sam?
650.25.
650.25, and when you square root it?
25.5.
25.5. So lads, this length here is 25.5. Upon completion of that, what is the next thing we need to do? Find RQ to what, guys? RQ? We're going to try and find RQ to the nearest meter. Okay? Now what does it say about QSR? QSR is what degrees?
42.
42, so not all the information was put in.
Yeah.
Now we can use I'm going to try the sine rule first. I don't think it will work. Let's see if it does. We're going to try, we want to find out RQ, so let's call this Y. So we say Y over sine 42 equals what, guys? The other sine rule? Pick another side. 18 divided by? Call it Z if you want.
That's what you use.
Sine Z. Okay? Now lads, either way, it doesn't work, does it?
No.
2 letters means you can't do it. We now go to the cosine rule. A squared equals B squared plus C squared minus 2BC cos A. What are you going to put in the A's position?
Thing.
What's the thing?
Y.
Y squared. Okay. What's A and B going to be?
16. 18.
18 and 25.5. 18 squared plus 25.5 squared minus 2 times 18 times 25.5 cos 42. Sam, when you put this into the calculator, what did you get?
Oh yeah, this got wrong.
So can somebody put that in the calculator now for me? Tell me what you get. 18 squared plus 25.5 squared minus 2 times 18 times 25.5 cos 42. What do you get?
292.043056.
04, yeah? Lads. Okay, square root that, please. What you get?
17.089.
17 points?
089.
So 09. Okay, so nearest meter, 17 meters. Okay.
So was that for 4-2?
Sorry?
That was all 4-2.
4 part 2. So this is 4 part 2 here, 4 part 1 here. Now, what's the area of the garden? Okay? So, there's 2 ways we can go about doing this, okay? The first way is we break it up into 2 triangles and we can use a half AB sine C twice, can't we?
Yes.
Now, there's actually a half AB sine C. So, what we're going to do is a half AB sine C. And for the blue triangle, I'll put this triangle in blue. What can we use? We can use a half 18 multiplied by 25.5. And what angle's in between them? Come on guys. What angle's in between 18 and 25.5?
42.
42. Okay. And what about the other triangle I'm now going to draw in red? What angle is here? 90. So we can do a half. Which 2 numbers?
12 and 22.5.
Sorry?
12 and 22.5.
12 and 22.5. And we can do this as sine 90. Will somebody put Josh, you did the blue one? Sam, you did the red one?
Yeah, 135 meters squared.
The red one's 135 meters squared, and the blue one, Josh?
153.56.
153.6. Add them together, lads. Add the 2 answers together. 288. 0.56 meters squared. Does that round up or round down? 289. 7. Okay guys, so question 7 shown on the board. Triangle ABC is there's a point D on the line BC. Find the following correct to one decimal. Find the length of DC. Well, DC, I can find this angle here by taking adding the two of these together and taking away from 180. Reason being, all three angles in a triangle add up to 180. So what's 180 minus 62 minus 70?
48.
48, is it?
Yeah, 48.
48. Now, I'm asked to find DC, which I'm now going to colour in red. DC I'm going to call X. So what rule should I use here? We always start off with the sine rule, don't we?
Yeah.
So X over sine what?
62.
Equals?
8 over sine 48.
8 over sine 48. The whole goal of the question is to get the X on its own. What you do then?
8 62.
8 sin 62.
Over 48.
And what do you get?
9.5.
9 point?
9.5.
Meters. Everybody happy with that?
Yeah. That was the DC, wasn't it?
Yes.
That's the question.
Now, lads, Sam, well, we gotta get next to the area of the triangle. If I shade in these two yellow lines here, what is the length of the second yellow line on the bottom? It's 9.5 plus
14.5.
plus 5, which is 14.5. So it's 14.5 along the bottom, and it's 8 along the top, and it has an angle of 70. What's the formula for the area of the triangle if you have an angle to use? Half AB sine C. And what do we get then? The half bracket sine bracket.
14.5.
Sorry? 14.5. 8 and sine 70. Put it into the calculator, let me know what you get.
54.0217.
54.5 to one decimal place. Centimeters squared. Okay lads. So Erin has been kayaking on a river and she arrived at a point on the southern riverbank. However, she wants to get onto the northern side. There are only two possible landing points she can see. One is slightly upstream from where she is now, and one is farther downstream. Because of the current, Erin can paddle faster towards the downstream landing than the upstream one. The situation in the diagram shows the banks of the river are parallel. Erin's position is marked D, so she starts off here. And the upstream landing is point A, and the downstream landing is point B. The angle from D to A and D to B are shown. The distance from B to A is 92 meters. If she travels in a straight line to A, Erin can go 0.9 meters per second. If she travels in a straight line to B, she can go 2.8 meters per second. Now, let me explain what's happening. It's like distance over time from junior cert. Okay? So that's, excuse me, if you find this length here, that gives you the distance going downstream, alright? So we'll call this distance x. Remember, time equals distance over speed. So the time taken will be whatever the length of x is divided by what number? She can go at 2.8. So the time taken to go from D to B is whatever the length x is divided by 2.8. Okay, so that's the time for that one. Now, the other scenario is you have a length y, which is this one here. Okay, and on length y, you have this one here. And we're going to say that this length here, the time taken to go to A is going to be what, guys? Whatever the length of y is divided by what? How fast can she travel up to A? 0.9. So do you understand? That's the answer to part 2. Find the time taken to get to each route. that alright?
Yeah.
Now, the next thing is, so there's two exit points. This is one exit point, this is the other exit point, and she has to get to one of them reasonably quickly. Now, what we can do is we can take all of these away from 180, and what do we get? What you get? You're going to get what? 101. Okay. Now guys, there's something called alternate angles in maths. Does anybody remember what alternate angles are again?
Angles are
If you have a Z or an N, this angle here equals this angle here. And the reverse direction, this angle here equals this one. There. Can anybody see any N's or Z's there?
Yeah.
See the Z here? I'll just shade it in a second. That means the other one is 45. Okay? So that's 45. And now, what about the other one then? There it is there. And that one also has to be 34. So, are you guys happy that with the information available now, you can do a sine rule to figure out what the length y and the length x is? You do two different sine rules, and then once you figure them out, you then do distance over speed to find out part 2, and then you answer part 3 using your common sense. Is that alright? I'll give you I'll voice over one more of these before I let you start. Okay lads, so what you have here is this. We have 3 triangles. Triangle 1, that's the first one. And then you have triangle 2, which is the big one. And then triangle 3 being the small one. So you can choose any 3 of these to use. If you're using the 2, there's an assumption to be made. You know when you're dealing with a tree or a building, what do you always assume? It goes up at 90 degrees. Okay, you're assuming it's a right angle triangle. Most objects stand perpendicular to the ground. And that's what we assume in the Leavens Art level course. Okay? So, first things first, it goes, measure angle elevation. She finds that the angle increased from 30 to 40 after walking 25 metres towards the church. What is the height of the church correct to the nearest metre? We need to find out what is the height of the church. Now, an interesting piece of information would be, if we can find out what this red line is, then we could find out information that is in the same triangle as the height. Do you see that?
Yeah.
So we have, I'm going to write down 2 triangles here. This one here, H 40 degrees, and whatever this length is here, yeah? Okay, I'll probably do this one out to be honest, right? So this one here, we have to find out what length X is. Now, can anybody in the class tell me, using the triangle on the left, which is now going to be in green, okay, the triangle on the left, which is going to be a very sort of steep one like that, okay, that's 30, that's 25 metres. Can anybody tell me what angle that is there? 140. Can anybody tell me what this angle up here is?
20.
10. Because that adds up to 180. Now, our whole goal is to find x. We can use the sine rule to do that. How do you use the sine rule to find that? X over what does?
X over sine.
X over sine 30 equals? Just keep that.
25 over sine 10.
25 over sine 10. And how do you find out what x is again?
Bring sine 30 up.
Bring sine 30 up. So you get 25 sine 30 over sine 10. Put that in the calculator. And we're up. What you get?
71.98.
71.98. Okay. Now this 71.98, it says the nearest metre, so I'll just call it 72. Lads, in right angle triangles, what are the special names we give to all 3 sides? Anybody remember? Adjacent, hypotenuse and opposite. So which one is H?
72.
Yeah, no, sorry?
72.
No, sorry. Oh yeah, sorry, you're right. H is the hypotenuse. What I call the height of the church is actually the opposite. You can give it a letter if you want, like y, so you don't confuse up h. So we have opposite and hypotenuse. Which function do we use? Sorry? Sine. And then when you use sine, you're going to get sine 40 equals y over 72. What happens now?
You do the inverse from
72 goes up there. And what's 72 sine 40?
46.
46.28. Now guys, it asks you, it's very important that you answer parts 2 and 3. They're really easy marks. In parts 2 and 3 what I ask you is, what type of instrument is used to measure the angle? It's called a clinometer. You would have seen me use it before.
What's it? Again.
What?
What's it look like again?
That's it. One step ahead of you. Okay, so it's basically what Sam is telling us there, right? It's basically an upside down protractor. Okay, and the upside down protractor, what it will have is it has a weight attached to it. So the weight is going directly downwards. So it's like a big line here. Now see the way that's reading 90 at the moment? Yeah? And then what happens is I rotate it until it goes in level with the church. And now you can see it now reads 120. So it was at 90, now it's at 120. Your first reading was 90, your second reading was 120.
What's the difference?
The difference is 30 degrees, and that's your angle that's presented in the church there.
Yeah.
Okay, and that's the clinometer. So in class now, if you guys could try number 9. Number 9. I want you to try number 12 and 13. 9, 12 and 13. 9, 12 and 13. What did I do in class today, guys? 4, 7. Shh.